Welcome to GyanBite. Today we're going after XSS, cross-site scripting. It's one of the oldest vulnerabilities on the internet, and it's still in the OWASP top 10 after more than 20 years. Why? Because it's deceptively simple. An attacker gets their JavaScript to run inside your page, and your browser has no idea it doesn't belong there. 20 plus years this has been in the top 10, not going anywhere. By the end of this video, you'll understand all three types: reflected, stored, and DOM-based, see a real cookie theft attack, and know exactly how to defend against it. Let's get into it. Let's start with the basics. You go to a website, you type something in a search box, for example, shoes. The page comes back and says, results for shoes. Simple. The server took your input and put it right into the HTML it sent back. Now, what if instead of shoes you type a script tag? The server doesn't know the difference. It takes your input, sticks it into the HTML and sends it back. Your browser sees a script tag and runs it. That's cross-site scripting. The attacker's code runs in the context of your page, with access to your cookies, your DOM, everything. It's not a bug in the browser, it's a bug in the server. The server trusted user input. Never trust user input. Reflected XSS. The attacker doesn't need access to your server. They craft a URL with JavaScript embedded right in the query string. Something like search with query parameter equals script, steal cookies close script. They send that link to a victim in a phishing email, a Slack message, or a social media post. The victim clicks. The server reads the Q parameter and reflects it right into the HTML. The browser doesn't know where that script came from. It sees a script tag on a trusted domain and runs it. One click. One stolen session. The code never touches the server's database. It bounces off the server and into the victim's browser. That's why it's called reflected. It reflects right back. Stored XSS is worse. Way worse. The attacker posts something, a comment, a profile bio, a product review, and that something includes a script tag. The server saves it in the database, no questions asked. Now every single user who loads that page gets the attacker's code running in their browser. The attacker posts once and walks away. Hundreds, thousands of users hit silently. They don't click a special link, they just visit a normal page. Ooh. The most famous example? The Sami worm on MySpace. One stored XSS payload spread to over 1 million profiles in 20 hours. Stored XSS is a landmine. Plant it once, it detonates forever. DOM-based XSS is the sneaky one. The server is completely innocent here. Your own JavaScript reads something from the URL, the hash fragment, a query parameter, and writes it directly into the page. The payload never hits the server. It goes straight from the URL into the DOM. Inner HTML, document.write, these are the usual suspects. Your server-side defenses won't catch it. Your WAF won't see it. Your server-side encoding won't help. It's entirely a client-side problem. If you're using inner HTML with any user-controlled input, you probably have a DOM XSS bug right now. Use text content instead. It treats everything as plain text. Let's see what an attacker actually does with XSS. The most common payload? Cookie theft. The injected script runs document.cookie. That gives it every cookie on the domain. Then it sends that cookie to the attacker's server. One line of code. A fetch call to evil.com with your session cookie in the URL. The attacker takes your session cookie, pastes it into their browser, and they are you. Logged in. No password needed. Remember the authentication video? Session cookies prove who you are. XSS is how attackers steal them. One XSS vulnerability can completely bypass your entire authentication system. That's why these topics are connected. 3 defenses. And you need all 3. They work in layers. First, output encoding. Never put user input into HTML raw. Encode it. Turn angle brackets into HTML entities. Turn quotes into entities. Most frameworks do this by default. React, Angular, Vue, they all escape output automatically. But the moment you use dangerously set inner HTML or VHTML or bypass the escaping, you're back to square one. Second, content security policy. CSP is an HTTP header that tells the browser which scripts are allowed to run. Set it to block inline scripts entirely. Even if an attacker injects a script tag, the browser refuses to execute it. It's your second line of defense. Third, HTTP only cookies. Set the HTTP only flag on your session cookie. This one flag means JavaScript cannot access it. Even with full XSS, document.cookie returns nothing useful. They can still do damage, but they cannot steal the session. Defense in depth. No single layer is perfect, but together they make XSS exploitation extremely difficult. 3 types, 1 principle. Reflected bounces off the server, 1 victim per click, stored, lives in the database, hits every visitor silently. DOM-based, never touches the server, it's purely client-side. Cookie theft, 1 line of JavaScript to hijack a session. The defenses, encode output, deploy CSP, set HTTP only. Every modern framework helps, but only if you don't bypass the safety rails. Next video, CSRF, cross-site request forgery. We'll show how an attacker makes your browser send requests you never intended. Subscribe so you don't miss it.